student. He's the superstar of section 8.2. A quadratic that has a plus c. But the nice thing is, let's review 8.1. 8.1 told us all about this A guy. 8.2 told us all about this C guy. So if this number, now some of you are like, why are there letters? They're so annoying and they're so frustrating. Okay, let me give you an example of one. How about y equals 5x squared minus 2? If you need like numbers to show you what's going on. What does this top number or this leading number tell us? If it's facing up, concave up like a cup, or facing down, which one? The greater than or the less than would have it facing up like that? Greater than, yeah. So this is our concave up. This is our parabola that has a min. That greater than says that you're going up, and that less than says you're going down. What else does that A tell us? Whether he's vertically stretched or vertically shrunk. This little A in front, whether he's a plus or a minus, I don't really care. We already talked about if he's a positive or a negative. And if that helps some of you guys, even my calculus kids, sometimes it's helpful for them not to think about the greater than or less than, but think about what it means. A positive number is greater than, a negative number is less than. Stretch or shrink. If I have a 5, that's something greater than 1. What's going to happen? Am I pulling the rubber band or am I pushing it?
Pulling it. Dang it.
And here's why. Ready? If all your heights are 5 times higher, hasn't your parabola got pulled higher? Right? So if it's 5 times higher, hey, that's going to be a vertical stretch. Why is there an orange? Yeah, but see the greater than or less than. Huh. Vertical stretch. And here's the awkward thing. If you're vertically stretching it, if you're pulling up, what's another way to make it go higher? Couldn't you also push it in? That's the weird part. It would be a vertical stretch. You could also call it a horizontal shrink. I know, it starts to be like, what? Yeah, you can either pull up or you can push in. It makes sense in real life. It's just hard when you put it to work. Okay, but if A is less than, now, okay, if this helps, A is something like 2 or negative 4 or something like 10. If I have anything that's bigger than 1, whether it's a positive or a negative, I'm going to get this stretching or pushing in to make it taller. But if I have something like A being 2/3 or A being 0.8 or A being negative 1/4,
Sure.
all those little ones are going to be a vertical shrink. But check it. What's another way to get a vertical shrink? Pull it out. Yeah, isn't that weird?
So
Every time you have one, it's the opposite of the other.
No, every time the A is greater than a number, it's a stretch.
Yeah.
Every time it's less.
Yeah, for the vertical, yeah. There's just that whole weird, like, you can also be pushing to get the exact same situation. Okay, that's the A's. And if you guys need, if it helps, that's kind of like a big summary now. Some of you weren't writing your tables. That's the hard part because you were kind of doing little swoops, but you weren't showing me where they were coming from. So I didn't know that your points were right unless you showed me a table. So this plus a table is like section 8.1. This is section 8.2. Section 8.2 says, what if I have a plus guy on the outside? So not just looking here, but looking here. Looking at this plus C. So what if I have a positive C? In homework, what'd you notice? If you added a number, if it was like a +3 or a +1 or a +10, what happened to your parabola? Went up. If it was a minus, it went down. So it's as easy as a vertical shift up and a vertical shift down. Which I saw most of you in your homework. You did all right. Where you got stuck, I heard from the beginning to the end of the room, was on that zeros part. So the zeros part, you're setting the whole function equal to 0, and you're solving by either plus and minus square roots or factoring. So I think from last night's homework, getting ready for tonight's homework, maybe the best thing that we can do is talk about that zeros idea. So talking about that zeros idea, that's where most of you tended to get stuck. Now remember, hold on, when you're graphing, you got to make those tables. I'm going to be checking homework very carefully, that big one that we're focusing on having on time. Make sure you make tables. You don't have to have tons of points, but at least have like 3 or 4 to help you out. But what about the zeros idea? In factoring. Factoring, we don't want to do that. Well, okay, we're setting this equal to 0. Whenever it says zeros, we're setting equal to 0. That's the first step, but we got to solve for x. Now some of you are like, well, just start moving stuff. Okay, that's one way. But the other way is we could use factoring, but factoring would say take out that negative always, always, always first. And if we take out that negative, it flips both of those signs on the inside. Who does this look like now from last chapter? X squared minus 25? Wasn't that one of those special ones? When you went to factor an a squared minus a b squared, could we do the x and could we do that 0 do? Yeah. Does anybody know how to factor an a squared minus b squared? Yeah, use those 5s. It's x minus 5 and x plus 5. And then what do we do to solve for zeros? Each one equal to 0. Each one equal to 0. And that's one way to get both that 5 and negative 5. Pause and sit. You guys have another 30 seconds because you started packing up a long time before the bell. But not just pulling out a negative, but couldn't we also pull out any GCFs? Anybody see that there's a 9 in both of those? And what do you notice about this guy? Isn't he also a? When you do zeros, what are you practicing? Factoring. Set each one equal to 0. And then let's see if that 0 thing can be easier than it was last night. All right, guys, I get up. Back up early. I gotta keep you late. Bye, guys. Remember, have that 1 on time. We'll catch up later. Have that 1 on time, ready to go for class.